Hello, and welcome to our IoT project for MEGR 3171. For our project, we designed and built a speedometer for a bicycle. So, we used two particle photons and a Hall effect sensor to accomplish this. Let's start at the back of the bicycle and we'll work our way to the front. So at the back here, we have our Hall effect sensor attached to the bicycle frame, as well as four magnets attached to the bicycle spokes of the rear tire. What we did is we measured how many pulses occurred over time to find velocity. And so the Hall effect sensor measures those pulses. When our magnet's in front of it, it sends out a pulse. And using some basic calculations, we can figure out what a pulse corresponds to distance traveled, i.e. through the circumference of the tire. So once we have our distance over time, we have our velocity. Now we can also calculate some stuff like acceleration and total distance traveled, but for the purposes of this project, we mainly just use velocity. That's what the display shows. But on our scene speed graphs, we have acceleration and distance traveled on those. Now, we call this the data acquisition photon. It's the one that mainly does the calculations, and it takes in the data from the Hall effect sensor that we just discussed, converts it to velocity, and then sends it over the internet to this photon here at the front, which we call the speedometer photon. So, this photon receives the data over the internet, maybe used through a hotspot on a phone or just a Wi-Fi network. And so it displays the data to the user through the use of an OLED display screen. And we use just velocity in miles per hour, but you could obviously convert it to whatever unit you wanted to use, or you could have it even display distance if you wanted to see that. But we figured velocity would be the most useful. And for two-way communication, what we did is we had this photon communicate back to that one if it had received data. And we had an LED light, you can't really see it in this shot, but at the bottom here, that would flash if it had received data in the last 15 seconds. And we use that to troubleshoot whether, should it be receiving data, well, we know it is or we know it isn't, using this LED light. Very useful for troubleshooting what we're doing. And as far as construction goes, what we used a lot of zip ties, but, if you want to use something more permanent, you could. We 3D printed the housings to hold this in. We have little doors on them that you can access both the photon as well as the battery pack. Obviously, the design for this one had to be a little bit different than that. But we tried to keep it contained because we knew since we're in a bicycle, there's going to be some wind and we don't want the wires to get blown out of the breadboard. We used a breadboard for this, a solderless one. And it's very easy to assemble. We designed them with fits in mind. And if you wanted to use this project for yourself, all you'd have to do really is customize the diameter of this little hold here. And we've made the models in SolidWorks and we've used relations so that it'd be very easy to do that. And that's about the introduction for this project. This is a more in-depth look at the Hall effect sensor and the magnets on the back of the bicycle. So you can see our Hall effect sensor is turned on, it's got a little red light on it. And you see our magnets haphazardly attached with zip ties. So if we spin our tire, you notice that every time a magnet passes in front of the Hall effect sensor, it lights up a little bit. And so that's it reading that a magnet has passed in front of it. So if we look at our speedometer display over here, we can see that it's displaying our speed, roughly 6 miles. Now, if I start, attaching a brake to this, it starts to slow down a little bit. And since, we're going over Wi-Fi, we're going over the internet, it takes a little bit of time for the speedometer to update. So if I start it back again from rest, you'll see the speedometer start to update. 4, 6. Now, if I start increasing the speed a little bit, trends back up again. And then it starts going back down to the friction. Applying the brake again. If I just stopped it rapidly, it takes a little bit of time for it to zero out. But that's a more closer look at our speedometer photon as well as our Hall effect sensor.